right, now let's work through a few examples. So let's suppose we have a company, in this case the NFL franchise New Orleans Saints, and they have a monopoly on their logo hats, which is true. And suppose that the marginal cost is equal to $18. So let's write that right here. $18 is the marginal cost. And let's say that this is essentially this is the demand curve for those Saints. We have a downward sloping demand curve. And if I just sketch it really quickly, you can see that at $30, no hats are demanded. And then it kind of goes down, 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 down. And then we have kind of the end of our curve is that 8 hats are demanded at a price of 14, right? So that's it. But we can use all the information from the table without having to go to the graph. So we're going to suppose that the Saints started at 22 and they want to lower the price to 20. And so we want to know what is the price effect and what is the quantity effect, and then what is the marginal revenue. So we can calculate the marginal revenue using this price quantity effect, or we can just calculate it directly. Let's do it both ways. So if I want to find the marginal revenue, remember that the marginal revenue is the change in total revenue over the change in quantity. Okay, so what is the total revenue initially at $22 is equal to 4 times 22, which is 88. And then what is the total revenue at 20? It's going to be 5 times 20. And we can see this trade-off. We're selling more things but a lower price, and so this is going to be 100. So essentially, the marginal revenue is going to be 100 minus 88 over the change in quantity, and in this case, the change in quantity is 1. So the marginal revenue is going to be $22. Right? Great. So, no, it's not going to be $20. That's not how we do subtraction. It's going to be $12 because that's what 88 plus 12 is 100. Great. So that makes more sense to us. We could also do this with the price effect and the quantity effect. So recall that what's happening is we're moving from about 22 to 20. And what's going to happen is that this is going to create a quantity effect and a price effect. Essentially, this little triangle here, let's zoom this in so you can really see this. This little triangle here, this is this rectangle, it's not a triangle, that's a rectangle, that's the price effect. And that's reflecting the fact that now we're charging, for our old customers, we're getting lower prices. And then we have a quantity effect here, which is that we're getting new customers. And that's going to be good for us. So let's see how that plays out. So the price effect is going to be equal to the change in the price times the old quantity. Essentially what that means is that now we're going to lose $2 per hat on the old number of hats we sold, which is 4. Okay? Then the other is the quantity effect. This is the change in quantity at the new price, because that's what we're getting out of it. We're getting new customers, we're getting one new customer, and we're getting, how much are we selling them for? We're selling them for $20. So we're going to get 20. So we're going to get $20 of new revenue. Essentially, we've brought in one customer who buys one new $20 hat, but then all of our existing 4 customers now pay $2 less. So we gain $20, we lose 8. So you can see the quantity effect is 20, the price effect is 8. If we add those up, we get that marginal revenue of $12. Now, as a monopolist, how many should they produce? Well, we want to produce where marginal revenue equals marginal cost. And our marginal cost is 18. So we want to produce where the marginal revenue is equal to 18. Now we found a place where the marginal revenue is 12. So that's not where we want to be doing things. Essentially what that is that if we've added $12 of revenue, we've also incurred $18 of costs. So our profits have actually fallen. So this isn't good for us to move from 4 to 5. We probably want to produce less. So how do we solve that? Well, what we want to do is we want to clear out everything we've got so far. So let's clear it all out. Bye-bye, everybody. We want to figure out what that total revenue is in marginal revenue. So we could do what we did before. We could just do it kind of step by step. I find it easier to calculate total revenue and then calculate marginal revenue, just like we had been doing before. So let's find our total revenue just by multiplying. So this is 0, 28, 52, 72, 88, 100, 108, 70 plus 42 is 112, 80 plus 32 is also 112. So what's our marginal revenue? Our marginal revenue is 28. Then it is, what is that, 24? Then it's 20. then it's 16, then it's 12, then it's 8, then it's 4, then it's 0. So marginal revenue is falling, and in this case, it's always positive. And we're very sure we would not produce beyond this because likely marginal revenue would actually be negative, and we don't want to be in that position. That's where that additional loss of revenue from the price reduction would actually overtake the quantity effect. So where do we want to produce? Our marginal cost is 18. So this is good, this is good, this is good, and then this one's not good. And that's not good because we want to get as close as we can without going over. So on that last one, we wouldn't produce, which means that we're going to produce 3 hats. And this is going to be our revenue. So what that means is that they should produce 3, and following the demand curve, they should charge 24. Now remember, it used to be in perfectly competitive markets, we would charge the market would bear what our marginal cost was, which was, we'd set marginal revenue equal to marginal cost, and marginal revenue was price. And so those things would all be 18. But here we've been able to kind of jack up the price because of that monopoly power. And if I wanted to figure out what those profits are going to be total revenue minus total cost. Here, total revenue is going to be price times quantity, and total cost is going to be ATC times Q. All right, so price times quantity is going to be what we already calculated here, which is 72. And we don't have an ATC, but remember that our marginal cost is constant. And if our marginal cost is constant, it's equal to the average cost. That is, if every additional unit costs me $18, the average cost is $18. So which means it's going to be 18 times 3. And that's going to be equal to 30 plus 20, 54. So it's going to be 72 minus 54. And so that's going to give us a profit of $18, which is not bad. So that's how we would work through a problem like that. Now let's do a question where we're asking how to identify the profit maximizing quantity and price of a monopolist, but we're using pictures instead of a table. So here we have a graphic of a monopoly market, and you know it's a monopoly market because of that downward sloping marginal revenue curve. That's really what's characteristic here. The marginal cost curves could go in all sorts of different directions. It doesn't really have anything to do with whether something is a monopoly or not. Or not necessarily. And then the demand curve is downward sloping because that's what demand curves do. So we want to figure out what the profit maximizing quantity and price is. So let's remember that our first rule is that we profit maximize where marginal revenue equals marginal cost. So we have to figure out where those two things are equal. So let's do it. I'm going to my marginal cost and my marginal revenue, and I'm finding that they're intersecting right there. Then I'm going to drop down for the quantity. So I'm just going to go and this one's a little bit tricky because I made my dot kind of large. It's hard to see where we are, but I think we're right at 70. So we're just going to say 70. And then I'm going to shoot up for the price because I'm going to say at 70, what will the market bear? Well, the market will bear at 70. It's going to bear right there. And I'm going to say that's 65. So that's our profit maximizing quantity and price. Now in this case, you can actually see the profits here aren't huge because the ATC is so high. Essentially what's happening is that the profits are going to be this little bit right here. So not huge, but they are there. In this example, I want to talk through another graphical example, but in a case where we can compare easily to what would be happening in a perfectly competitive market. So what we can know from this problem is that the marginal cost and average cost are a constant $20. So I'm just going to draw this right here. Try again. There we go. And this is MC, and it's equal to ATC. And so the first question is actually about what happens in a perfectly competitive industry. So in a perfectly competitive industry, we can't use this marginal revenue curve because this marginal revenue curve assumes that you're a monopolist and you have some control over the price. If you're in a perfectly competitive industry, you have no control over the price. So how do we know from this graph what the market price is going to be? Usually we're told it. Well, the one thing we know about perfectly competitive industries is that when they're in equilibrium, companies are producing at their minimum ATC. In a situation like this, our minimum ATC is constant, so it's always just the ATC, which means that in a perfectly competitive market, this is going to be the price. It's going to be equal to the ATC, reflecting that long-run equilibrium. So as a result, where do we maximize? We maximize where marginal revenue equals marginal cost. We're going to ignore that marginal revenue curve because that's just for monopolists. which means we're going to maximize where P equals MC, which is going to be at P equals 20, which is going to be where marginal cost equals 20, which is where everything's 20. So what does that mean? That means that this is where our price is going to be. And then how do we know how much to produce? We're going to produce right at the demand curve, where the two things intersect. And so let's go down here. And what this means is that I'm going to produce 8 units, in this case of pay-per-view subscriptions for football games. And how much am I going to charge? I'm going to charge 20, because that is the average total cost, and we're in equilibrium. Profits are going to be 0, because marginal revenue, the price, is equal to marginal cost. So there's no profits. All right. Now, what if I want to know what the consumer surplus is? Well, the consumer surplus is the difference between the demand curve and the price, which for this perfectly competitive industry is going to be this big triangle here. And then what is the producer surplus? The producer surplus is another way of saying profits. We know what the profits are. They are 0. And what's the deadweight loss? There is no deadweight loss. Perfectly competitive markets are efficient, so there is no deadweight loss. Everyone who wants to make a trade is able to make a trade. Everyone's happy, except for the producers. They don't have any profits. So now, let's suppose we have a monopoly. How does this change our graph? Well, it changes everything. Specifically, what it changes is that we're no longer producing at this intersection. This intersection is dead to us. This is no longer our consumer surplus. All of this is gone. What does matter, of course, is where this marginal revenue curve and average total cost curve is, because our monopolist, just like our perfectly competitive firm, is always going to optimize where marginal revenue equals marginal cost. But now marginal revenue has its own curve, reflecting the fact that monopolist's revenue changes because of those price and quantity effects. So we're going to produce right here at the intersection between marginal revenue and marginal cost. What does that mean? That means that quantity is going to be 4. And when we say what is the price, we must remember that the price is not the ATC, because the monopolist has market power. It can raise the price, and it will raise the price up to the demand curve, because that's what the market will bear if they're only selling 4. So they sell 4 at 60. That's great. So let's write that down. That means that Q is 4, P is 60, and we can see that's a higher price and fewer quantities sold than it was in a perfectly competitive market. And I can even calculate my profits. I'm not going to do the math right here, but you can see that the profits are the difference between the ATC, the price, times the quantity. So it's this. This is the profits. These profits are equal to the producer surplus. So where's the consumer surplus? The consumer surplus, relative to what we had before, is much smaller. It's still there, but it's much smaller than a perfectly competitive market. And that's partially because the monopolist is able to see some of that surplus. So for the consumer surplus, it is again the relationship, the area between the demand curve and the price. It's this whole area, and so that's the consumer surplus. And now we have a bit of area that is no longer claimed, and this is our deadweight loss. This is where there would be trades. People would be willing to buy more subscriptions if the price were somewhere between 20 and 60. But the monopolist has found that it's most profitable to do it this way. And you could kind of imagine it, right? So like, let's suppose that the price was a little bit lower. Let's say that this was what they decided to do. They decided to produce here. That is, they lowered the price to 40 and decided to sell more. You can see that this box, this gray box of profits is going to be smaller. This blue box of profits is smaller than this gray box right here, which is highlighting the fact that this is not profit maximizing. It's this box that gives the monopolist the biggest chunk of consumer surplus. So that is the idea for how we would calculate this.